Good afternoon. Today we're going to be talking about graphing derivatives, and this is a bit challenging and extremely important. So we're going to spend a few days on this one. So let's remind ourselves what the derivatives are. The derivatives are the slopes of the tangent lines over an entire interval, whatever the interval is for the graph. All right, so no exact directions or steps on how to do these. You just got to look for some certain things. So that's what this list is here. Just a list of them things to be careful to look for. First off, the zeros. That'd be the place where the slope changes from a positive to a negative or a negative to a positive. So these would be f of x graphs, meaning that these are the actual original graphs. If you see a graph moving up, hitting a peak, and then coming back down, like it's called a local or a local minimum or a maximum, those would be the places where the slope of the tangent line at that spot would be 0. So again, that's something that's important to note. Some other things to remember about slope, that if you have that perfect 45-degree angle diagonal, that's your slope of +1 or a -1. And then something that's kind of going to take a little getting used to is when you have a consistent slope, that the derivative slope is flat. And that's going to be one we look at in our first example, because that's a little hard to understand. And then don't forget about open circles at points where the graph is not differentiable. And that's what we worked on yesterday, was finding those points. All right, so let's try an example. We're going to graph the derivative. And again, we're graphing the slope. And we're going to do it at specific points. So one thing to look for is to look for a spot where the graph curves and we have this local maximum or a local minimum. But sadly, because that particular spot right here where we have that is a corner point, not a smooth curve, that's not differentiable. I'll have to have a circle at that spot, an open circle, because again, not differentiable there. So some other things to look for, again, are those consistent slopes. You can see that the rise and run on this section over here on the left is consistent. It's a flat line. And that slope would happen to be rise 1, run 1. That has a slope of 1. All right, so for example, if I came to the spot on the graph where x is -8, so we're looking here, and we're looking down, and I'd want to know what's the slope of the tangent line at that spot, because that's the y-coordinate on my f prime graph. So the slope of the tangent line, like I said, for that one is 1. So on my f prime graph at -8, I'll come up to 1. All right, let's jump a little bit farther ahead. Let's see what's happening where x is -6. What's happening not to the y-coordinate, but at the slope. And again, like I said earlier, the slope at the tangent line for a linear equation like this one in this section is always the same as the actual slope of that line, which would be 1. So at -6, I'm also at 1. And let's jump over here to at -4. And again, the slope of the tangent line there would be the same because we have this nice consistent graph. And again, that 45-degree angle, the slope is 1. And then what about here at -2? And we're still looking at that same -1 slope. It does the same thing all the way up until this point right here at 0. All right? So that is going to be a nice, consistent, smooth line. But then right here at 0, that's a point of discontinuity, or not differentiable at that point. Not discontinuous, but not differentiable. So that means we have an open hole. Now let's look on the right-hand side. For example, over here at +8. Let's get rid of these ones. So over here at +8, what's happening to the slope? Well, the slope isn't positive anymore. Looks like it's a negative slope, and it looks like that 45-degree angle looks like the slope is -1. So when I'm at +8, it looks like I got a -1 slope. So over here at +8, I'm down at -1. And then what's happening here at 6? Well, it looks like to be the same consistent -1 minus 45-degree kind of angle thing. So again, I'm at 6, -1. Well, what's happening here at 4? The same exact slope's happening at 4. The slope hasn't changed. What about here at 2? Well, again, at that particular spot, the slope of the tangent line still hasn't changed. But back here at 0, again, that's where it becomes undefined. So that's where I got a hole. So I got this pattern that's happening. So that's my f prime. All right, hopefully that makes a little bit of sense how I got it. But like I said, this is going to be something that's not necessarily instinctual. It's not hard to do. It is just not instinctual. It's not obvious. It's going to take a little bit of thought. You're going to make some mistakes. And again, we're going to spend a few days on this one just because of all that. All right, let's try a little bit trickier one. All right, so this time, let's look for those zeros, and I got one right here. It looks like right there, that's the bottom of a graph. So that means at -4, the slope of that tangent line will be 0. So when I graph that, that's one of those zeros. And then it looks like it happens again right about here. So when x is 6, it looks like the slope of the tangent line will also be 0. All right, so again, those are some key points to kind of start with. All right, now let's look and see at things like, for example, let's look in between the two red dots. What's happening in between the two red dots? It looks like that's a pretty consistent slope. It looks like those slopes of those tangent lines would be all really, really close to that 45-degree angle in the positive direction, or 1. So meaning, maybe right here the slope of the tangent line is 0, and then right here it's a little bit closer to 1. It looks like the farther away I get, the more close it gets to 1. So it looks like that's going to drop down a little bit, and then by the time I get here to right in this area, it looks like that slope of the tangent line's pretty much, whoops, I shouldn't have dropped down, I should have gone up towards 1, because remember, it's a positive slope. And then from here, at the y-axis, from here to that spot right there, the slope of the tangent line would again be somewhere in that range of close to 1, but eventually as we got closer down to point at 6, that slope would have to be back down to 0. But that whole section had a positive slope, so notice that the graph is above the line, whereas this section over here and this section here have negative slopes, so the graph of my derivative will be down below the line. So let's take a look. Again, the one on the left, let's look at the green one on the left over here. So again, if I think, for example, like what's happening here at -8, what's happening there to the slope of the tangent line? Well, it looks like it's definitely negative, and it's kind of steep, and a little bit maybe close to that -1, but maybe a little steeper than that, like maybe -2. So over here at -8, maybe I'm down here. And maybe here, if I looked again at -6, what's happening? And again, at -6, it looks like the slope of my tangent line, which again would just run right next to it, kind of, would be, again, right around that -1 zone, or close. So maybe -1.5 or something like that. And again, you can see the pattern here. Same thing's happening on the right. And if I'm looking at what's happening, that's all negative slope, so my derivative graph should be below the line. And if I just kind of pick a spot like what's happening here at +8, well, again, it looks like at this spot my tangent line's pretty close to that -1. And again, you can see what's happening on this side. You don't have to graph a whole lot of dots. You don't have to graph every dot. It doesn't have to be a perfect graph. We're just looking kind of for an in general what's happening. All right, and again, it's awkward because it doesn't match the graph at all, and it definitely takes some thought. So I'm expecting you to have some questions and some struggles on this. And again, we're going to spend the next couple of days working on it because it's not simple and obvious. It's going to take time. All right, so if you get stuck at anything, you know how to get a hold of me. And again, if you're a little panicky about not being perfect at this, know that this is not going to go away in one day. We're going to stick on this for a few days. All right, good luck today.